Well, good afternoon, everybody. Thank you for joining me for this Civil Survey Solutions webcast on intelligence sections for civil site design. My name is Jonathan Taylor. I'm an applications engineer based in New South Wales in Sydney. Today is going to be all about intelligence sections. So I'm going to ask you run a quick poll very shortly just to see who out of those of you that are sitting there watching at the moment have tried out intelligence sections. But certainly I think this is one of those tools which maybe only a few of you have tinkered with, and hopefully after watching this, what is going to be quite frankly a superb webcast, you'll be able to go away and start to play with these and really begin to see the benefit of them. And obviously by the end of it you'll have had enough of my my witty humour as well. So if I can get this to move on, just so you're aware, the recording for this webcast will be available via the website. It'll also go on the welcome screen for those of you that have got access to that. It will be downloadable as an MP4, but if you are keen on getting the download straight from the website, all being well, it should be there. I would suggest in the next couple of days. If you do find it's not there after a couple of days, please hound us, which some of you do very kindly do, for a link, and we can send it to you. Future reference, upcoming webcasts currently, although it's not shown on this slide, there is another webcast in a couple of weeks' time for cul-de-sacs, knuckles and roundabouts, which again I'll be doing, so get yourselves onto that if you want to. There will be a short I'll just flick back. There will be a short survey afterwards, 5 questions, 4 of which are just multiple choice, and just the 5th one is just for any additional comments. So if you find that the quality, and I mean in respect of video and sound, is not brilliant, you'll get the opportunity to let us know about that at the end. And also just a couple of general questions about the webcast, just to give us feedback. It's always useful to get that. There is a Q&A panel. I'm not too sure if any of you can see the Q&A panel. I have been told by one person that it's possibly not running, but there's a questions panel. With any luck, you can pop those questions in there. I have got a colleague, Shane, at the other end, who may be able to see those. We're not too sure, but if we can address them at the end, we will do. If we don't, obviously I'll get you guys to fire those over. So with respect to today's agenda, really I guess this is to go over the fundamentals of intelligence sections, because if you haven't seen these before, then they're going to be a bit of an eye-opener. Certainly there's a little bit of learning involved with using them, but once you understand the concept of how they work and what they can do and the power of what they can do, certainly I'm sure you'll get some benefit from that. I've got a little poll which we've never run before, but I can actually ask the software or ask this webcast software just to produce a little poll, and hopefully you'll get a little question appear on screen, and it's essentially asking you if you've ever used these before, ever tried playing them with them, even if it's for 5 minutes, or even if you've tried for a couple of days using them, just to let us know. So I'm going to hit launch. Hopefully you should now be able to see the poll, and I should get some feedback. So far, one of you's voted with 100% of no. In fact, 5% of you. Here we go. 78% of you have voted. Resoundingly, at the moment, 81%. 92% of you have not used these. About 11% have at the moment. So that's extremely useful to see, knowing that you know, this is one of those tools which really only 10% of the user base, based on this straw poll, of use. So it's quite handy to see. Really, the agenda is going to be focusing on helping you understand how to get started, how the form works, and then we're going to see practical application of the intelligence sections and really constructing 5 different conditional section types for you. There are going to be sort of 3, I'm saying intermediate, there's no such thing as basic when it comes to these, because they are, in their nature, they're not basic, they require a little bit of thinking. So I've put the word intermediate there, but we're going to batter to an alternative surface, table drain with a batter, or batter to a table drain, which is actually probably more what it's going to be like, widening with a batter. Some of you may have seen some very brief YouTube videos with these in, but really we're going to be going through them in a lot more detail. And then we're going to be doing something probably far more complex, which is to essentially batter and then do some depth checking after that batter to determine what to do next, followed by a benching example. Okay, so we'll have a quick look at some of these I'm going to run you through the five different options that we're going to run through. If you've used multi-section batters, I should have put a question actually, who's used multi-section batters, but if you've used multi-section batters in the past, then these are essentially replacing that. As far as we're concerned, multi-section batters are a legacy tool. The 5 different conditional sections that we've got are predominantly based on requests that I've had or we've had from customers. Okay, so this is one of the most common ones, I guess, that pops up in training and then there or thereabouts. Most of the examples that or pretty much all of the examples that I'm going to give you I'm trying to put into some kind of context to try and make sure that you can essentially try and see how these could relate to something that you're doing rather than just apply them to any old job, stick them on Marin Street, which is, you know, one of our favorites. But I'm going to use this particular example, batter alternative surface, with a subdivision, because let's face it, there are occasions where you've maybe got some grading going on in some lots and you want to batter to that surface for the grading rather than batter to the natural. So in this particular example, you can see that on the left side of the template I'm actually battering to the natural surface. However, on the right side of the template I'm actually battering to the natural surface minus ½ a meter. But again, this could be any surface. The second one we're going to do is when we're in a cut scenario, so this is a rural road template, but when we're in a cut scenario, we're going to be battering at 1/6 to the natural, and then forming a small piece of section between the end of that batter and the bottom of this, what's essentially going to become a V-drain. And then all we're going to do is batter back up to the natural surface. So in this example, we've actually got 2 batters on both sides. Okay, so it's something a little bit different. This was a situation that came about from a council wanting this type of thing to be applied. I'm actually just sticking in some model view as well, not to be fancy, but actually it gives you a little bit more context so you can actually see some of these settings and how they're going to be applied. So you can't necessarily see that that's in cut, but you can see we've got the batter at 1/6 and then we've got our little V drain occurring at the end. Third example, we're going to widen the carriageway. Now, it's a bit misleading me saying widen carriageway because it sounds like we're taking a code and we're moving it, okay? And we're certainly not going to be doing that. We're actually creating a section, okay? So much like if we were creating a section using a variation or using the template editor or template creation tools, we're actually going to be creating a section, and then we're going to be battering down to the natural surface. One thing the reason why I'm showing you this one is essentially because apart from the fact it's in fill, I want to show you how you can add subgrade as well. So I'm actually asked the subgrade here to extend through to the edge of construction and show you how that can be set up as well. Quite important. That's the scenario. Again, hopefully you can see the contrasting colours, but we've got our widening occurring here. You can see down the far end of the screen that the widening has stopped because that's we're in a cut scenario, but we've got the widening in fill and then batter down to the natural, or any surface for that matter. This particular scenario is where we begin to get very complex, okay? So I'm going to try and take you through this step by step when we actually get in there, and hopefully it'll make some sense. Essentially what we're going to be doing is one check first of all, okay? So I'm going to ask the software, so this is again this is going to be a subdivision example, and what I'm going to ask the software to do is to see if it can strike a batter from the end of my template to a surface, which in this case we'll just say is natural to make life simple, for 2 meters at 1/4, okay? So if it can strike the natural surface within 2 meters at 1/4, we want it to do exactly what you can see on screen there, which is essentially what this topsoil rendering is in here. If it can't strike the natural surface at 1/4, we still want it to draw that section, but then it's going to have to make 2 decisions. If the depth after it's drawn it is less than ½ a meter, then I want it to batter to the surface at 1/1, okay? If the depth at this particular point here is more than ½ a meter, then I actually want it to draw a very small sort of base segment here, sort of ½ a meter flat, and then batter or put a retaining wall into the natural surface. Okay, it could be any surface. I'll show you how that's changed shortly. So essentially this, although it looks like it's a retaining wall, is actually a batter at some ridiculous, where you can see it's 1 in 0.001 it's slope wise, so it's extremely steep. So this is where we begin to get into the sort of more conditional stuff, checking how things are happening. Then lastly, we're going to be adding in a benching scenario. So looking fairly straightforward with this, there's a couple of tricks that I'll show you in respect of the subgrade and model viewer as well, which I'll come to in a second. There's also a trick when it comes to putting this kind of thing in with an alternative surface. So as a running theme, I'm going to be adding in a secondary surface, which happens to be half a meter lower than the natural, to show you if we wanted to bench to that instead, how there is a little trick that we have to look at. I'll come on to this in a second. That's essentially what we're going to end up with. Okay, so for those of you that have used Model Viewer extensively, you may have noticed actually on the previous slide, I've got code after code after code, which the software automatically creates. And for those of you that have used Model Viewer would know that you apply material between a code. However, as the more codes we get added in, we haven't created material for those extra codes. So I'll show you a way in Model Viewer how you can just ask the software. It's a very, very simple, straightforward process, but how you can basically ask it to add a particular material to any codes that it hasn't recognized. Right, here we go with a little bit of theory. I'm going to try and make this as straightforward as possible because whilst it's easy to describe a form, in some cases it can be easy to show you the practical nature of it and talk you through it. But I'll talk you through this bit first, and then once we've done that, we'll look at the practical application side of things, and hopefully I'm going to do a very good job of trying to run this through. So I'm going to start sort of top left, work my way down. You'll see the red boxes appear. Hopefully it'll make some sense as to what I'm explaining to you. So first bit's very straightforward. It's essentially saying to you that the current table is saying to you what's the current name of the template that we're editing. Okay. Any templates that get created are go into your data folder. So you can see I've got an add icon and then the delete icon. So any new ones that I add go into my data folder. Any that get deleted obviously get stripped from my data folder. Inherently, these files actually come as default from your common folder, which, as you know, if you understand the concept of a data folder, whenever you start a brand new job, a copy is taken of your common folder, and these are where these templates come in. Going forward, though, when you click on Add, they're continually getting added to your data folder. I'll show you in a minute how you can save them out to the common folder for future use. And in actual fact, folks, I've actually got the, I'm going to give you a link and you'll be able to have access to these 5 different templates and download them, and using these, this little bit of instruction here, you'll be able to load them in. The second part of the form is essentially describing really all the actions, so and then checking and essentially telling the software what to do, which I'm going to come to in a minute. There's no point me really describing through that in much more detail without you actually seeing it in practical application. But you can see there we've got a cut tab, which is telling the software what to do we're in a cut situation, and we've got a fill tab, which is telling the software what to do we're in a fill situation. The next part of the form is for those of you that have used, pretty much any other form in our software that's fairly new. You'll see that we've got the option to move items up and down, insert rows above other rows, editing a row. The nice thing about intelligent sections is that it uses the double click function, so I'm just going to be simply double clicking on items to edit them rather than coming down to the pencil icon. Delete item and save and load. Okay, so this is essentially when you click on save, the save folder will default to your common folder, at which point you can obviously save the template or the section that you're currently working on to your common folder, and every new job that you open going forward, the theory is that that will be in there ready for you to use. You've also got the load option. So the load option I'm sure will be useful to you for if you're going to be taking these sections that I'm creating, you can load them in from the zip folder that I've got. Once you've unzipped it and put it in your common folder, you'll be able to paste that, bring these styles in. There's a button here called Set Cut and Fill Conditions to Match. We are not going to use that button, and in actual fact, it has been a cause for some confusion for different users. In fact, me, when I was first looking at this particular module of the software, it caught me out as well. So whenever you see Set Cut and Fill Conditions to Match, it might look like a nice, simple, straightforward button to click on. In fact, I'm not even going to describe to you what the consequences are of clicking on that, but you maybe by the end I'll come back to it and explain why you shouldn't really ever be ticking that, and it will hopefully make more sense to you once you've seen it. Right. Now, here we get into sort of the nitty-gritty of how this works, okay? So essentially, intelligent sections work as a sort of a series of action and creation tools. Okay, so the software within this part of the form here is going to start at the top of the list and work its way down. Okay, essentially what happens is you normally start with a check, which is what these logic actions are, and then tell the software what to do or create depending on the result of that check. Okay, so if the check fails, it's going to do something called jump to the next line, which we'll see in action. Or if it passes, we can actually tell the software to jump to a specific place in our list, which again you'll see in a minute, and perform an action. Now a colleague of mine, Shane, likes to put it as an adventure storybook, which this got mentioned to me at the weekend as well, which was, this is going to be a very short anecdote, but it got mentioned to me at the weekend as a good way of explaining this situation. So essentially it's a case of saying, right, I'm at a particular position in my book. When I get to a particular decision, okay, once I've got to that decision, I'm going to go to a particular chapter. It's going to say, right, you need to go to chapter 5. When you get to chapter 5, you're going to do something. So essentially, I probably haven't done a very good job of explaining that or using that analogy, but essentially it's that kind of theme. So if you understand adventure storybooks, if I've even used the correct terminology for that, then you'll understand this, but I'm going to talk it through in a bit more detail anyway. Logic actions. So these are essentially a check and a decision. So it's going to check something and then make a decision to jump somewhere, okay, which I'll come to in a minute. So it's like saying, well, I'm going to check this and then go to a particular chapter in the book. The first thing is test depths. So essentially this is checking for a depth range at the end of our template. Okay, so if the check passes, we can go and do something. So it's basically go to here, go to a particular chapter. Or if it fails, it's going to do what's known as go to the next line, which again we'll see in action. Test intercept is essentially saying check for the interception of a batter at the end of our template within a certain width. So we might say, I don't know, go across 4 meters at 1 in 4 and see if you strike a surface, a particular surface which I name. If it passes, we can tell it to go and do something. If it fails, it goes to the next line. Okay, and again, you're going to see all this in action. So I'm running you through the theory, but the practical application this will cover it. Go to is essentially a sort of a shortcut button which says go to a particular part in a place in our list and perform a function. Okay, so it's sort of like as I said, it's a shortcut. Undo to marker, and in actual fact add marker as well, are related to undoing something. Now we're not going to cover that in this particular webcast, but essentially it allows you to undo a section. Okay, but I wouldn't get too worried about it. It's not something we're going to be covering. Logic items. So these are essentially like chapters in a book. They act as a place to jump to in the list. Okay, so add comment is essentially just as if you were using a comment in a variation or even adding a comment on a form of some sort within the software. It's just a null and void item. It just acts as a marker for you to write something. Force finish actually tells the software to stop. Okay, so if it performs a certain function, you can say, right, go to chapter 3, do something, and then stop. I don't want you to do any more. Okay. Labels. Now labels are going to be very, very probably going to be the most commonly used item in logic items because essentially this is the way it could work. You could say, right, check my depth. If it's between 0 and 1 meter, I'd like you to go to a particular label. That label is effectively a chapter heading. So go to chapter 1 and then do something over here. If my depth is between 1 meter and 10 meters, I'd like you to go to chapter 2. And that's what the label is. The label is just a chapter, and then it performs this. So it performs a data item. The data item is essentially the creation or drawing. Putting mildly, it's just drawing something. So let's put that into perspective. It's check something, go to, and perform an action. Okay, so I'd like, in this case, width by slope is saying, well, look, I'd like you to go a certain width. This is like drawing a section on the template in the template editor. Go for a certain width at a certain slope. Certain width by a certain crossfall. Same item effectively. You're just putting in a crossfall instead of a slope. Width to surface. You're essentially saying, right, go this set distance, and I would like the end of that point to be matched to a surface, a bit like using a variation, and the same goes width to string as well. Essentially the same type of thing. You're referencing a string and saying, right, we'll go to this particular string and use the levels for it. So again, like the variations you would have used. Batter, probably the most common item in here because pretty much everything nearly ends with a batter. I would suggest, not always, but pretty much I think in all of these we'll have a batter entry, which is essentially saying, right, batter to a particular surface. And then lastly, benching, which will be our final example where we would actually get a bench, as you saw in the in those drawings earlier. We'll run, as I said, we'll run through this in practical application. I'll just run you through the rest of the form. So essentially the central area of the form is to give you a visual description as to what's happening with your design, much like if you're using the template editor. One thing I mentioned down here is zero depth is, essentially you may find that you end up with a code sitting right on top of a surface, and I mean actually on it, okay, so they're the same level. When that occurs, you might actually want the software to form some kind of batter to an alternative surface, okay? However, because the depth is 0, it won't do it. So there's an option in there which I'll try and remember to come back to, which I haven't highlighted on this form, which is to say, right, use, if there's 0 depth, if I've got this scenario here, where there is 0 level difference between the surface and the code, then I want you to assume that it's in a fill scenario and it's going to undertake a fill calculation. On the right-hand side of the form, essentially it's all our display control. So much like other aspects of our forms, you can go through and change the way in which this looks to give you an idea as to how your design may look in a particular scenario. Really, the only element I'm going to be focused on, I'm focusing on tools which really I personally use. Okay, so there may be elements to this which you find, well, that could be useful, but I'm trying to run through this within obviously an hour, but I also make sure that I'm using really the fundamental elements of the tools to make sure you fully understand them. There's an indent option in here which I'm going to cover in a second, which enables you to sort of space each line an indent to make it a little bit easier to use. Right. There's a couple of rules for the fill and a couple of rules for the cut. Essentially they're the same, but I want to make sure you fully understand them. So the best way I could do that was to sort of describe it visually. Essentially, when our last code on our template is in cut, i.e. it's below the sampled surface. So what we mean by sampled surface is it's the surface that you've sampled when you've created your road or string object. In this case, we're going to make life nice and simple. We're using the NS, that's our sampled surface. When we add a cut entry, and you saw the form earlier, this is the cut part of the form. When we add a cut entry and we put in a value, the software will always project the slope up by default, okay? Because it's in a cut scenario, okay, it believes that the code is underneath that surface and it will project the code up. You may be thinking that seems completely logical to me, but there are going to be, in fact, the first example we're going to look at is an example where that rule we'll need to look at how this works and revise it. When it comes to depth, the depth range is always positive. So if I want to say to the software, right, I want you to check if I'm between 0 and a meter of cut, I put in a value of 0 to 1 meter. Okay, and again, that might seem logical to you now, but when you put in fill, you actually have to put in something slightly different. Speaking of fill, again, I'm going to reiterate this now, and it will hopefully make more sense by the end why I'm going through this now. So when the last code is in fill, i.e. it's above the sampled surface, okay, the fill slope always projects down. So if I say to the software batter at 1 in 2, okay, it's always going to batter in a downwards direction. Okay, there's possibly some more technical way of putting this, but I'm really trying to put it in a method which hopefully you'll understand. Depth range is always negative, okay, so this is the complete opposite. So if I wanted to say, right, check if I'm between 0 and a meter of fill, I actually have to put -1 to 0 in the box, okay. Don't get too worried about it because ultimately I'm going to go through this very shortly, in fact pretty much now, as a practical application so you can see how it's applied. I'm going to have to whittle through this because there's a fair amount to get through. I'll cover this at the end, but essentially this is the download. If you want to take a screenshot right this minute, you can do. That's the download for the templates that I'm just about to use, but I'll make sure I leave it on the screen at the end. Right, let's shut down PowerPoint. So We're going to use batter to alternative surface, so I'm going to do a couple of examples in this job and a couple of examples in a rural road project. We're going to batter to an alternative surface. So for those of you that are using Civil 3D, all I've done is essentially created a second surface called NS, which is a copy of the NS, with NS pasted into it, as you can see there, and I've lowered it by ½ meter. Very, very straightforward. For those of you that wanted to try this in the BricsCAD or AutoCAD version, and you download this, you will need to create a second surface. So in Surface Manager, all you need to do is if you've got NS in the project, obviously I don't because it's Civil 3D, you could say copy surface, and then go to the editing tool and lower it by ½ meter if you wanted to try it that way, or if you've got secondary surfaces in your project. Absolutely perfect. Doesn't have to be NS minus ½ meter. It just so happens I'm using that one. Right, so first of all, I'm just going to open up the cross-section window for Hobart Court, which is going to be our first intelligence section. Now, at the moment, for some reason, I think I might have left the intelligence section from a previous test in place. I have, so I'm just going to delete that, just pretend that wasn't there. This is what we've got at the moment, just battering at 1 to the natural. I'm going to display my secondary surface. Okay, now my secondary surface can be displayed by clicking on these buttons here, which is an absolute mouthful to describe, default objects for cross-section view. I'm going to ask the software to display all objects, sorry, in all roads, show a surface called NS minus ½ meter between 0 and 1000. There's my ½ meter lowered surface. It's deliberately in there to show you where we're going to batter to and try and give you some context. I'll also jump into model viewer as well. It's going to strike auto model because it was battering to the old surface. Right. I'm also going to try and leave where I can the cross-section open on screen so you can see this all happening and being applied. So to start this off, we need to find intelligence sections, and intelligence sections lives underneath the create section button, create edit section button, and you can see we've got create edit intelligence sections. Once the form is open, you will get a default list of intelligence sections in there, which I said come from your common folder. I've actually got already in here the final intelligence sections, which are the ones you guys are going to have if you want to download them. So I'm actually going to be starting from scratch. So logically, if I'm starting from scratch, what I can do is just click on the create new table button. I'm going to call this batter to lowered surface. Try and be as descriptive as possible, because if someone else picks this job up, you don't want them to be trying to working out what on earth your intelligence section is all about. The more descriptive it is, the better. It's already in use. That's right, because I've just created it. Let's just call that batter to surface minus 0.5 meters. So okay, yeah. Right. Now, this is where we start. First of all, we're not going to be doing any checking. Okay, all I want it to do is to batter to an alternative surface. I don't need to check the depths. I don't need to tell it to go anywhere. I just want it to simply draw something, which is why I'm going to come down to data items. So I'm in the cut scenario. The cut and the fill are going to be identical. I'm going to go batter. Now, when I add a batter, it's essentially saying how far should it look to form this batter and find the surface. Well, I actually want it to just keep going until it strikes the surface. So I'm actually going to put 1000 in here. We're in a cut scenario. Okay, so if I put a positive value in here, it means it's going to look up. It's going to look up for a surface. Okay, the surface, I can actually pick any number of surfaces. So I'm actually going to say surface 1. In the design data form very shortly, I'm actually going to tell it what surface 1 is. Okay, but you could pick any number. Very simply, all I'm now going to say is, right, well, if there's an elevation adjustment or an offset, I haven't found a use for those yet, but I'm sure there is. I just personally haven't found it within these scenarios. If it can achieve this, I want it to simply end the batter. Okay, so if it can find the surface within 10,000 meters at 1 in 3, which I'm sure it can, I want it to end the batter. So I put end batter, and then I put BAT for a code. Okay, so this is exactly like you would do if you were forming a template in the template editor. BAT for batter, it will work out whether or not you need L or R for the prefix for the left side or the right side. Do I want to plot this code in my cross sections? Well, yes, just like any other batter code I probably would do, and click OK. You can see in the preview that's now battered up to my surface, which is exactly what I want. Now I'm going to go to the Fill tab and I'm going to go to Batter, and I'm going to do exactly the same thing. 1000. I put in a positive value, which means that it's going to go down. Okay, I want it to look down, which means I just put in a positive value. To the surface, once it sees the surface, end the batter. Go BAT and click OK. Right, that looks to me, well, you can see from the preview, like what we've got looks pretty good. Okay, so all I'm going to do now is close. To apply this, all I want to do is now go to the design data form. So I'm actually going to click on this button here. For those of you that don't know, you can get to it via this. And we're going to add a batter entry. Batter entries, there's intelligent sections. I can click OK. And how do I want this to be applied? Very straightforward, 0 to 1000 on both sides. What's the multi-section template that sorry, not multi-section, that's not the word to use. What intelligent section do I want to use? Well, batter to lowered surface. And what surface? So I could do this twice. I could say, right, batter to one surface on the left, and batter to surface 1, and batter to a different surface called surface 2. It's up to you, but we're just going to say both. So you've got, this is why you've got multiple surfaces. I'm going to put NS minus half a meter and hit add update, and this is what you get. Okay, let's just move this out of the way because hopefully you're going to see this failing with any luck. Let's just make sure it is. Yes, it is. Okay, I'm going to close the design data form and just move this cross-section window out. One thing you'll notice is that for some reason it hasn't battered to our natural surface. Okay, and this is the bit which catches people. Okay, now eventually you'll see that it does. Now, it really goes back to the behavior or the rule that I mentioned earlier. When the software is in a cut scenario, so a cut scenario is it's below the sample surface, which it is there. When it puts in a cut value, the cut value or the cut slope always projects up. Okay, so I'm in cut and it's trying to project up, which obviously it can't do because there is no surface for it to find. So to resolve this, I actually have to add another batter entry in the cut scenario and actually tell it to go in a minus direction as well. So let's see this in practice. So let's just go to, this is the, as I said, this is the bit which catches people. Just takes a little bit of getting your head round. Batter to lowered surface, and there it is. We've told it to go up at 1 in, or go at 1 in 3 until it sees that surface and end the batter. Well, because it's going up, it won't ever strike it because it's under the sampled. So we add one more batter entry. So I'm going to go 1 in 1000, 1000 meters at -3 to a surface and end the batter. Okay. Now, if I close this, unfortunately, we are hoping to get an apply button because the only way at the moment I can reapply this is to actually go back to the intelligence section form, re-pick it, simply just pick it back again and hit add update. And in the background, you would have seen that's now battering to the alternative surface. So this is the bit which will trip you. You'll wonder why your batter hasn't occurred, but it's really only the batter scenarios where this will be the problem. Always just add in the second batter entry with the minus value, and this will essentially resolve that for you. But really, this type of thing occurs when you add a secondary surface. If this was the natural, it wouldn't matter. Okay, but it's because we're referencing a second surface which isn't the sampled surface. Okay, so you're probably going to rewind this bit of the video and just watch it again, but hopefully that should make some sense to you. We'll encounter this a few times, and I'm going to try and make sure you understand how we resolve it. But it's essentially the resolution is doing what I just did, adding a second batter entry at an alternative slope. Right, to make life easy, probably going to delete that one in a second. Let's just, I should have hit auto model there just to make sure that's all now tidy. The reason my total has gone off on its own is because obviously there was no batter there and it's getting a little bit confused. But in model viewer, I don't know why I'm opening it actually, because you're not really going to see the detail. Let's just close that down. We'll look at model view in some of the others where it looks a little bit better. We're going to jump into the rural road scenario now, and we're going to apply the second option, or the second section, which was a batter and then a table drain at the end of that batter. Okay, so we're going to go to intelligent sections. First of all, let's maybe just turn on the secondary surface. So again, I've got the same thing in here, just a secondary surface, just for the purposes of playing around with this, to show you how you can end up with little issues that you need to resolve. There's our secondary surface. I'm going to go to create edit intelligent sections, and we have one in there. These aren't your traditional intelligent sections. These are ones that, as I said, I've already created, and I've actually deleted the ones that were already in there. Don't suggest you do that. I'm going to add a new entry. So the entry is essentially when we're in a cut scenario, I want to form a batter and a table drain. So I'm going to have a batter and table drain in cut. Nice and descriptive, so it tells me immediately what I'm getting. So we're on the cut tab. Okay, so first things first, this is where we want to actually test, because in a fill scenario, I don't want it to do anything particular, I just want it to batter. So only when it's in a cut scenario do I want it to perform a function. So I'm actually going to come to test depths. And as we checked earlier, we always put positive values. So I'm going to say, right, if I've got any cut whatsoever, okay, so this would mean that I'm going to say from 0 to 1,000,000 depth of cut of a particular surface, which in this case will just be our natural, surface 1, okay. If it finds that and it passes, I want it to go to the next line, okay, and we're going to create the next line very, very shortly, okay. Click OK. So it's done that, okay. Now if it passes, what I want it to do is to batter up to the natural surface. Now, bear in mind, it's not going to fail. Okay, there's no way that can fail, because it's going to be, unless I've got some significant issues with depth, it's never going to fail that depth check. Okay, so we don't have to worry about it failing. First thing I want to do is say batter. So this is why the batter entry is so commonly used. You can just put search for 1,000,000. Go up at 1 in 6 until you strike a surface, which I'm going to say is just going to be the natural very shortly. Once you get there, I don't want you to end. I actually want you to go to the next line. So I want you to do something else after this. However, we still need a code. Okay, much like if you were creating codes on a cross-section, you'd need to make sure you've got a code. I can put BAT here. The software should, by default, add in a prefix with numbers 1, 2, 3, 4, 5, 6, 7, etc. if I leave the same code in there. Let's click OK. That creates a batter for me in the cut scenario. Now, the next two parts of this are very, very straightforward. First of all, I now want to create essentially a V drain. Okay, so the first part of this V drain is just going to be essentially just a section of line at a particular slope for a set distance. So I'm going to use the button width by slope. So it's just all we're doing is just drawing things. So I hit width by slope. I'm going to say to the software, right, go at 0.5 meter. Now, knowing what we know about falls, in a cut scenario, if I put a positive value in, the cut scenario, the slope of the line segment will always be drawn in an upwards direction. Okay, so I want this to go down, so I'm going to go say -4. And then I'm going to put in a code, and we're going to call this TD1, table drain 1, or V drain, whatever you want to call it, and click OK. You can see that's now formed that over here. Now we've done that. All I'm going to do is actually add another batter segment. Okay, so simply adding in another batter by clicking on batter down here. The width doesn't really matter. However, I want it to go up at 1 in 4. Okay, so that matches the slope value I just popped in for my width by slope segment there to the natural surface, which we're going to specify in a second. And once it gets there, we'd like it to end the batter, followed by code BAT. You can see it's added BAT- well, you may not be able to see, there we go, BAT-1 has now been added in on there. So you don't have to worry too much about your codes if you don't want to. Okay, that's the cut scenario. I'm happy with that. Now what to do when we're in a fill scenario? Well, I actually want it to just batter. Okay, so I'm going to come to the fill tab and simply batter. So search for the surface within 1,000 meters or 1,000,000 meters, whatever you want, and batter at, say, I don't know, let's put 1 in 3. okay, because it's 3, and in a fill scenario, don't have to worry about minus or anything like that. In a fill scenario, when I put in a value, it will automatically look downwards, okay? Surface 1, what to do when it gets to the end. I want it to end the batter and finish, okay? So I can click on OK. So that looks to me like it's probably okay. In fact, it is okay. Just so you're aware, the little indent by button here is really useful. We'll see this, you can see what's happened up on my coding up here, or sorry, my line work up here. It just sort of spaces everything out for us. So if I wanted to just have everything split up, only slight downside at the moment is that it forgets, once you close the form, it forgets the indent, which is slightly frustrating, but at the moment, you can just come in and flick that across and just gives you a little bit more clarity on what you're doing. I'm going to close that down. We're going to come to the design data form now and look to apply this. So I'm going to click on our rural road and come over to batters, add the batter, intelligence sections, click OK, 0 to 1,000. Both sides, again, doesn't have to be both. Which template rule do I want to use? Batter and table drain in cut. What surface am I reference? What surface is surface 1 going to become? Well, it's going to become my NS. Let's produce a cross section and pop that up so we can see what happens. So we're in cut now, so hopefully this should get an immediate impact. That's fantastic. There we go. So as we flick through, wherever in cut, you can ignore the second surface. That's not it's not a consideration in this particular design, but you can see now as soon as I'm in fill, it batters at 1 in 2. Okay, nice and straightforward. Now we're going to jump on to essentially something, we're trying to get sort of a little bit more complicated as we go along, okay? As I said, these are sort of designed to be fairly straightforward. I'm going to close that down. Sorry, these first 3 are designed to be fairly straightforward. In fact, if we just pop into Model Viewer, one thing I didn't do, when you do this for the first time, you'll find that all of your coding, let's hit Auto Model. Auto Model is important, otherwise Model Viewer, sometimes Model Viewer won't update because I haven't told it to update Auto Model. Let's just see if this is going to work. Auto Model, please. I haven't hit refresh in Model Viewer, so let's just pop into Model Viewer, hit refresh. There she is, look. Fantastic. So it's going all the way through. So when you get this, you'll initially see everything in red. So you'll see, because the codes you've created are brand new, the software doesn't know what render material to apply, so you can right-click and assign material group. So I put topsoil deliberately to give a bit of contrast rather than everything being green. I'll leave Model Viewer open just to show you how that can just be left. Right. Now we're going to look at widening the carriageway, followed by a batter down to the natural surface when we're in a fill scenario only. Okay, so I'm going to come back to creative sections, add entry, and we're going to go, in fact, I've got to make sure I don't use the same name as what I've used previously. No, I haven't. Okay, so I'm going to actually widen out by meter. Widen road with batter. Okay, I could put the batter slope in this description if I wanted. So cut scenario we'll come to in a minute because we're not too interested in what's happening in the cut. What we're interested in what's happening is going with a fill. So the first thing I'm going to do is to say, right, well, test depth. Okay, I'm in a fill scenario, so I need to go from 1,000,000 to 0. Okay, if my code is in that amount of fill of a particular surface, in this case it's going to be the natural, then I want it to go to the next line and do something. It's not going to fail unless we've got some serious depth issues on our road being 10,000 meters deep, which I'm sure we don't. Okay, once it's done that, I'm then going to ask it to perform, or essentially form, a segment which is going to be the edge of our road. Now, rather than using width by slope, I'm going to use width by crossfall. So it's essentially the same thing, just using a different value. The width, I'm actually going to put a meter in here, and the crossfall is going to be 2.5%. Again, it's not minus 2.5. If I put minus 2.5, it will go up. When I'm in a fill scenario, all slopes go down. Okay, so 2.5%, and I'm going to call this SE. Nice lengthy code names. That's going to be RS, right shoulder extension or left shoulder extension. Okay, just felt like putting something rather large in there. Click OK. Okay, that's performed. So rather than the software actually performing a widening of our road, we're actually kind of creating the widening ourselves. So it's a bit misleading maybe, but you know, we're essentially saying, right, I'm going to widen out by this set distance at this fall. Once you've done that, all I'm going to do is now simply batter. It seems to be the same thing every time, and that's pretty much it is. It's the same scenario. Batter 1 in 2 down to the natural surface. When it gets there, end the batter and put a code in called BAT and click OK. I'm going to pop in the cut as well. So the cut, I just happy to have just a slope of 1 in 2 surface, and go to end batter BAT and click close. Now we're going to apply this. Going to go to the design data form. This bit's the bit. Now I've deliberately left this entry in there just so I can swap it over. So I'm just going to flick it to widen road with batter, add update, and hit auto model. Now we should hopefully somewhere see this not sort of broken, but it should be having an issue somewhere. Now I'm just going to flick along here. So it seems to be working okay at the moment. We're all in cut at the moment. I want it to go into fill. There we go. So there you go. It's in fill. It's widening out. You've got the extra code going in on both sides. Now there is a tiny problem, okay, and you may have spotted it on the left side. You may remember, and again we keep covering this, when we batter. So at the moment, this is all part of a fill entry. Okay, so it's a fill scenario, and I've told it once it gets to the end of this code, it needs to batter to the natural surface at 1 in 2, which is what it's doing over here. However, because it's in fill, it's looking to project that slope in a downwards direction, and the natural surface is not in a downwards direction. Okay, so hence why it's not able to find it. So what I've got to do is to now go back to my create edit intelligent sections, find my entry, find the fill scenario, and where I've got batters here, you can see it's going at 1 in 2, so it's looking downwards. So I need to add another batter entry looking up. Simply, all I'm going to do is put -2. Okay, surface 1, end the batter. So I'm actually going to put a comment on here. My colleague Shane's done this a few, and it's a good way of understanding why he's done it. So he generally puts something called fail safe if code ends below, or you put above if it was the cut issue, ends below sampled surface. So that immediately tells me that I've got one batter here which would work normally, but if my code ends up below it, obviously I've got a fail safe in there. So I'm going to click close, and to simply reapply this, come back into my entry, simply pick it again, add update, and you can see that that code has now gone in, which is exactly what I want in that scenario. Now, let's look at how we can sort out our construction underneath here. So there's two ways you can do this. First of all, we can either ask the software to extend these two sections or these two layers of subgrade and extend them to the edge of construction, or we can add our own brand new construction in here and ask that to extend. I'm just going to do the former, which is to extend these two layers of construction only in a fill scenario to the edge of the batter. Okay, so to do that, all I'm going to do is to go to create edit section. Sorry, not create edit. Yes, no, create edit section. You'll see my template set up here, and essentially it's these two codes I want to edit. So I'm going to go edit subgrade. In fact, I'm not going to go edit section. I'm going to click between the two. Here's my two layers. Assign layer control. And all I'm going to do is ask it to extend. So this is layer 1. So this is the first layer of my subgrade. This is the second layer of my subgrade. You can see we've got two over here. I'm going to say, right, in a fill scenario only, extend these layers all the way through to the edge of my design. Now, if my crossfall of this segment or this new section I've just added in, this widening, was different, I would probably want to pick and add subgrade in for those individually. But I'm just going to hit apply and exit. Okay, that. And there we go. So what it's done is it's pushed this through, because this this widening is also at 2.5%, I can push it straight through without there being a problem. If you didn't want to do that because maybe this widening had a different slope, you would do the slightly different method, which is to set subgrade. So I'd say, right, between, I'm going to have to just move this over a fraction, between this code and this code. So right shoulder and right shoulder extension. I'm going to go right shoulder and right shoulder extension. Add your material, and then essentially run that design extend if you want to through that process. But that's one way you could do it, or the second way you can do it if you want to. Unfortunately, we don't have time to progress into that. Right, we're getting very short on time. I guess I just wanted to show you really how you could not necessarily break the, oh no, we've done that. We have, I say break it, I don't mean to say break, I mean to trip or work out what we can do with this scenario. Let's just jump into the next options. This is where it begins to get a little bit more complex. Unfortunately, my notes are completely the wrong way around, so I'm just going to make sure that I'm looking at them the right way. There we go. The subdivision project is what I'm going to use for this. Particularly I'm going to use Melbourne Drive, which is this loop road going around. So again, this is sort of a scenario that I've come across with customers. In fact, two customers, one wanting to put on a batter and then decide whether or not there's going to be a retaining wall. But this is also a good way of working out, if you're running, how much space you may have in a lot once you've performed a number of tests. So this is essentially going to be broken into sort of two chunks. So let's look at this. So create, edit, intelligent section. We're going to create a brand new section. Now this one's a bit complicated, so I'm going to try and word it as best I can. Batter with check for retaining wall or slope. So essentially it's going to batter at a certain distance, and then once it's done that, check for depth and then perform an action. Now, rather than check for depth, I'm not interested in depth so much. What I'm interested in is checking whether or not a particular slope at a particular distance will strike a surface. Okay, so this is where I can use test intercept. So we're in the cut tab. This is basically where we want this to check. So if the inside, I'm going to move this out of the way, if our lot here is in a cut scenario, our road is in cut, I want it to batter. Then if it's still in cut by a certain depth, produce a slope, or if it's really quite deep, produce a retaining wall. So, and it's going to be on the right hand side of this road. So this road goes all the way around and it's on the right hand side. We want to perform this. This could be useful for the subdivision people. So let's go test intercept. I'm going to say, right, go 2 meters at 1 in 4. Okay, so this means it's going to go up 2 meters at 1 in 4 and look for this particular surface. Okay, once it's done that, go to the next line. Okay, there's no point saying end batter at that particular point because it won't have drawn anything. Let's click on OK. If it passes, okay, we've said you need to go to the next line. So if it passes, that means it can strike my surface at 2 meters at 1 in 4. So that means I can draw a batter for 2 meters at 1 in 4. So I'm going to go batter, the width 2 meters at 1 in 4 to a surface, which in this case is surface 1. Then end the batter. Okay, that's all I want it to do. If it can do that, perfect. And click OK. I'm going to put the indents on over here just to make sure we can sort of get a sense of how this is coming together. So that's essentially the first part done. Now, if it fails, I want it to actually, obviously it won't go to the next line, it will actually go to the one after that. So if it fails, I now need to tell it to do something. Well, I actually need it to draw a segment of batter for 2 meters at 1 in 4. Okay, so I'm saying batter, I don't mean that, I mean a section. It needs to draw a section. Okay, then we decide, depending on the depth, what to do next. So hopefully as I draw this, it will make a little bit more sense. So let's go width by slope. We're going to say 2 meters at 1 in 4, and let's call this left bottom of the left top of slope, left TS. It doesn't really matter what code you're putting in, and click OK. So let's have a look at this. We've said, right, if the software can strike a surface 2 meters at 1 in 4, then batter to that surface and finish. Okay. If it can't, it's going to go to the next entry, which is to draw a slope at 1 in 4 for 2 meters. Okay, and obviously that isn't a batter because it's just stopping short of the surface. Okay, so now we have to ask the software to perform some checks. This is where we begin to get into adding something called labels. Okay, so at this particular point, I wanted to check the depth. Okay, in a cut scenario. So simply, I'm going to say test depths between 0 and half a meter. We're going to use half a meter as a sort of a rule of surface 1. I want it to do something. Now, this is where the chapters come in, or labels. Okay, so if it's within this, I want it to go to chapters X. If it's within a certain depth range, another depth range, I want it to go to chapter Y. Now, at the moment, I haven't added a label, so I can't get it to go to one. So I'm going to click OK. All I'm going to do is just add the other option in, which is test depths between 0.5 and 1,000. So if it's greater than a half a meter of the natural or a surface, then go to another chapter, which I don't have at the moment. So that's my checks ready. I now need to have chapters for them to jump to. Okay, so I'm going to add labels. This is where labels come in. Really simple. In fact, you can see how simple it is. So all I'm going to put is a chapter heading. So this is where I have a depth, if I can spell, which is less than 0.5 meters, and click OK. I'm going to add one more label. Click on Add Label, depth, which is greater than 0.5 meters, and click OK. Now I can come back to the test surfaces, and I've now got chapters for them to jump to. If I go back to test surface, you can see here between 0 and half a meter, go to depth less than half a meter. Okay, and then it's going to perform an action. In this case, it's going to draw something. And the same goes with the one that's greater than half a meter, between half a meter and 1,000. Go to the chapter, which is called, or label, which is depth greater than half a meter, and click OK. Now, once it performs that action and that one passes, it's going to jump to here. If this one passes, it's going to jump to here. Okay, so this is essentially how it can be set up. Now I can't remember if I should have done half a meter or a meter, but it doesn't matter too much. You'll see the general principle of this going in. So I've added my label. Now I need to tell it, if it comes to this chapter, what to do. So I'm going to ask it to draw something. Okay, so if it's less than half a meter, I actually just want it to batter at 1 in 1 to the natural. Okay, so I'm going to hit batter. Go for 1,000 meters at 1 in 1 to a surface, and if you intercept the surface, which you're going to, batter. Click OK. Okay, and you can actually see that's happened on screen. Now, it should essentially, because it's ended the batter, that would finish. Now, if it's greater than a half meter, I actually want it to do a couple of things. First thing I want it to do is to form a little line or a little slope for half a meter and then project up. So this will make a little bit of sense, hopefully. So width by slope, half a meter at 1 in a billion, so basically flat. And we're going to call this going to call this bottom of retaining wall, and click OK. Once it's done that little flat bit, I actually want it to project up a retaining wall, so I'm going to hit batter. We're going to put 1 in 1,000, I guess. The slope of this batter is going to be 0.01, and the surface I'm going to project to will be surface 1. And if it finds it, which it will do with those parameters, I want it to end the batter, so BAT. Then click OK. Okay, so essentially that's formed for us our template. Okay, and now we can go and see this being applied. So hopefully this will we should make some sense. So let's click Close. We're now going to go to the Design Data Form, click on our road, add batters, intelligent sections between 0 and 1,000. On the right side only, batter with check for right retaining wall or slope, and what surface, the NS. Now let's bring up a cross-section through our design. If we get time, I'm not too sure if I'm going to get time. I was going to batter to an alternative surface, but I don't think we'll have time for that. The version that you will have will actually work. I'll have that in for you now. I think it's because I've got slightly different values in here. This isn't quite as big as I thought it would be. But anyway, look, you can hopefully see now that where it's 1 in 4 and it's greater than half a meter, at the end of that 1 in 4, it produces this little retaining wall for me. So as I flick through, you can now see that it was able to form the batter it intercepted the natural surface at 1 in 4 for 2 meters, so that's all it drew. So we flick through, and as we come up to the top of the drawing, got about 1 million sampled sections. Okay, there's a bit of an issue there. What haven't we done? We haven't put a fill batter in. So very quickly, let's just quickly pop in the fill scenario. So fill, batter, 1,000 meters at 1 in 2 to the natural surface or a surface, and end the batter. You can see how this is becoming pretty much the same thing most times. So let's click close, jump back in here, find our entry, repick it, add update, and auto model. That's why it's looking a little bit, it was looking a little bit bare. So let's have a look at this in model viewer. Pop into model viewer, and then we're going to jump onto benching because we've getting very short on time. Only like model viewer will pop up there. There we go. So let's just have a quick look in here. Might be because I've just managed to open up model viewer twice. There we go. I have popped in a different code to that I did earlier, but you can essentially see in here I've got the 1 in 4 being formed. In fact, this is a good place to see it. 1 in 4. If it reaches the natural surface within half a meter, it's battering at 1 in 1. If it doesn't, it's drawing a retaining wall for me. So if I wanted to start playing around with materials on here, I could right click, but you can see how that's being developed nicely for me, so I can see what's going on, see where I need a retaining wall. Again, this is where model viewer sort of comes into its element, because you can really start to see the visuals of your design as opposed to just being stuck on plan. Right, we're going to very quickly just jump into the final option or intelligence section, which is going to be benching. So we're going to jump back into the rural road design, and let's just quickly run you through how the benching tool works. And if we get a chance to, well, I'm going to have to try and show you this within the time, where we've got some issues with the sampled surface again being below in a cut scenario, so we'll show you how that works. Benching. So we're going to keep this nice and simple. I'm just going to add an entry and just call it benching. Now, what I suggest you do is try and be descriptive and preferably try and spell correctly as well. So it's 0.5 meters horizontal followed by a vertical of 0.25. Okay. Now we want this to be in a cut and fill scenario, so I'm just, in fact, for time, I'm probably going to put this just in cut. Okay, but the fill scenario is going to be identical. We come down to benching because we just want it to form benching. Now, bearing in mind that we could add benching after it's done a number of different things. So in that previous scenario where we had the retaining wall, we could have then asked it to start forming some benching. So this can come in at any point. The benching form is possibly a little bit more simple than it initially looks. Essentially, you're asking it, telling it what surface to use. Okay, the depth range. Okay, and because we're in a cut scenario, it's going to be positive values. Then we're going to say to it, right, well, look, what's the face value going to be for any of my benching? So I'm going to say, well, look, it's going to be half a meter and go up 0.25. Okay, so if I wanted to put a slope, I could do. I'm going to call this top of wall or TW for my code and click plot. And then the bench, so the flat bit. So half a meter, 0 height, and call this BW. Now it will add, as I said before, as we saw earlier, a suffix onto this and automatically change that for us. Let's click on plot that code. So if I'll see that code come up on my cross-section plotting. Up here, this is the part of the, where you can see now, this part of the form basically tells the software what to do when bench or the face intercepts a surface or it gets within a certain range. So you can see here, if face intercepts surface, then we can say, right, actually accept the intercept. Okay, so if the face projects up and into the surface, what we could actually say is, well, look, I'd like you to accept the entire face. Okay, so there are going to be scenarios, maybe if you're doing gabions or something, you can't do half a gabion, so maybe you want to accept the entire face. Okay, where in this case, we're just going to say accept the intercept. And if it intercepts, I want it to stop. Okay. We've got some interception options, okay? So the face and bench are essentially identical, okay? But it's just telling it to do something for the face and something for the bench. So I'm going to say if it gets within 100 mil, okay, of my surface, then I want you to intercept Okay, so I don't want it to just sort of draw a very small 100mm segment of face. I want it to intercept if it gets within 100mm. That means end batter. Okay, same goes with the benching. Okay, so if the bench intercepts a surface, i.e. the flat bit projects onto the surface, then I'd like to intercept. You can do a number of things. I'd like to accept the bench, stop the bench at the intercept. Maybe I'd like to do that, and I'd like to end the batter. Okay. Same goes with these options down here if you want to get it to do certain things with the interception. Now down here you can actually ask the software to repeat the process a number of times. So if you're restricted on width, or you can only go a certain number of steps, then you can say, right, well actually I'd like you to just repeat this 10 times. I'm going to put 0, which means it's basically going to crack on and keep going until it finds the surface, which could shoot us in the foot. And then end batter. Okay, if I wanted it to do something afterwards, I'd say next line and then click OK. And you can see that's drawn that up for us nicely. Let's click close. I'm deliberately avoiding the fill part because I want to show you a trick with this on the sampled surfaces again. Let's click bench. Let's bring up a cross section. And I'm going to click somewhere here because I know we're going to get something. That's possibly the worst place because there's going to be virtually nothing there. Let's pick somewhere here. Here we go, and hit add update. Of course we're in fill. That would be the case, wouldn't it? So I'm just going to again, the worst point to be able to pick a cross section. Let's pick one here. Okay, let's try and flick through here a little bit. Oh, there you go. You can now see it's all happening. There we go. So that's doing its job. Essentially, it's forming the benching where it should. Now, that in itself is fairly straightforward. What I want to show you is what happens, okay, where we have, with any luck, when we're battering to an alternative surface, okay, and I think this cross-section might have the problem. You may remember what we've been looking at with respect to assigned values. I'm going to leave this cross-section open because I think this one's going to trip up. And I say trip up, it's going to do what it should, but it will show us that there's an issue with what we've put in. Let's just flick back and change the surface to the lowered surface and hit add update. Okay, this one works, and the reason why is because we're in a cut scenario. So all the values we put in are positive, which means they always look up, okay? There's our surface sitting below. We have a tiny problem. So how do we resolve that? Well, let's just minimize the cross-section window. Let's go to cross-section edit, create edit section. Let's pop to our benching scenario, and we're going to have to create this again, okay, but put in values for it to actually begin to look downwards, okay? So to do that, I'm going to go bench, surface. The depth range is the bit which you might be thinking, well, I'll just put a minus value in for the height. You actually need to get it to look down, okay? So I'm actually going to put minus 50 to 0. Okay, which means that it's looking for a depth range which is below the natural. The width 0.5, the height is going to be minus 0.25 this time because we're telling it to look the other way or project the other way. 0.5 and 0. This is all the same as before. We have top of wall, bottom of wall. Plot the code, and I'll just quickly fill these in as we did before. Accept the intercept. Not going to worry too much about face options. I'm just going to ask it to intercept using face, end the batter, leave that as 0, and then end the batter. So it's essentially going to draw it all up, and if it intercepts, it intercepts. Let's just check this is going to work. Let's click close. Let's bring up our cross section and just reapply it. There we go. So that's the trick with that. I wanted to make sure I showed you that. I know I haven't put anything in for fill, but essentially if it's below the sampled surface in cut and the surface it's referencing is below the code as well, you need to add in that other option, which is why it's produced that for us there. Now I appreciate we've overrun on time. That's everything I was going to cover minus 1 or 2 little bits. That's everything I wanted to cover today. As I've said earlier, I'm just going to bring this up now. Just going to right click and bring up this PowerPoint presentation. Just going to cycle through this until I get to the very end. If you want a copy of those intelligence sections, there is one of them which is the one with the batter and the optional retaining wall or slope, which has got a little extra calculation in there. But if you want them, you can go and download them as a zip file from here. If you've got any questions, please fire them through on the questions panel. I'm not too sure if any of you have managed to, some of you are actually asking me about the poll and if I've closed it. Hopefully that was no longer on your screen. We've got a survey that's being performed at the end of this, so if you can please just take the time, hopefully it's just the best part of a minute just to complete that survey for us, just to help us improve in any areas when it comes to webcasts. Let us know the quality as well. The recording will be available via the website very shortly and the welcome screen. I don't think we've had any questions, which is unusual. It either means the webcast was that good or it hasn't made a lot of sense. But I'm not seeing any additional questions coming up. I'll just see. Yeah, no, I'm not seeing any at all. If you have got questions, guys, please email us. Drop in. Try some of the intelligence sections that I'm giving you on this file. I would also recommend that if you do start to play with them and you're not getting them to work, please ping them through and we'll have a look at them for you. It's great when we see people sort of really getting into the depths of the software like this. So please have a good go at them and see how you get on. But hopefully this has been a huge amount of use to you, and we look forward to seeing you again next time. Thank you for joining us.